Welcome, everyone. My name is Chris Paoli, editor, and I am pleased to be moderating our first session as well as welcome you to today's Application Security and DevOps for Enterprise Summit, brought to you by VMware Tanzu. The editorial staff of Virtualization and Cloud Review and ADT Mag have worked hard to bring together some of the best independent experts on this topic for this event, so we really hope you enjoy it. Before we start today's event with these three great sessions, we do have some announcements. First, we wanted to let you know this event is being recorded and will be available for future viewing. You'll receive an email with the replay is available, which will be generally in the next couple of days. Each of today's three sessions will be followed by a 5 to 10 minute Q&A, so please be sure to put your questions into the Q&A area of your console as they come up, so we can get them answered for you. During today's third session, we will be giving away a high-end 3D printer, but you must be present to win, so be sure to stay on for the entire event. Finally, we do have some resources from our sponsor VMware Tanzu available on your console right now, so please download and check those out. It's because of VMware Tanzu's underwriting of this content that we can bring you this summit, so we thank them for sponsoring and supporting the community and ask you to check out these resources so we can bring you more events like this in the future. Now on to the first session of today's summit, Shift Left Security, Why Enterprises Should Embrace It. This session features Stephen Smiley, AWS Solutions Architect, Intervision Systems. Stephen Smiley is an AWS Solutions Architect with Intervision Systems, where he leads the AWS Security Consulting Program. He focuses on enabling innovation by making security fundamentals accessible and actionable rather than a roadblock. A former military intelligence officer, Stephen balances strategic and tactical thinking to help you accomplish your objectives. Take it away, Stephen.
Awesome. Thanks so much for having me today. Let's see, I'm going to move the slides here forward. So today I'm talking about Shift Left Security. Okay, there's my headshot. Hey, so today we're talking about Shift Left Security. And actually, thanks for the great intro, Chris, but I have one update. So I am now working with a company called ScaleSec, and I'm no longer with Intervision. And ScaleSec, we are all focused on cloud security and compliance, automating that, security and compliance in your environment. And we cover, everything from advisory to hands-on engineering. And so especially if you're doing things in AWS or Google Cloud, we'd love to talk to you about your cloud security challenges and how we can help you with that. I personally am a big AWS guy. I'm an AWS ambassador. I've got the AWS certifications here on the screen to show it. And I actually just renewed my AWS security specialty exam yesterday. So it's fresh in my head. So if you got any questions for me, let me know. But today we are talking about, shift left security, particularly from an enterprise perspective. And so, first of all, what is it? Well, depending on, what term you want to use, shift left may mean DevSecOps, it may mean continuous security, but ultimately what we're talking about is the integration of security into your, agile IT processes seamlessly and transparently, really. So when we talk about shift left, we're imagining this timeline of security on the right as, a final check before something goes live. And so shift left, the essence of it is, hey, don't wait until the end, right? Shift that process left. Now, my only problem with that term is that we don't really want to just shift it left and then ignore the right side either, right? We want it throughout our development cycle. And so I've got on the screen here, the kind of classic DevOps big figure eight, if you will, showing all the steps that you go through when you're developing stuff, right? From planning and creating, packaging, and so forth. And you'll notice that there's no security step in there because security is part of each of these steps, right? Security should be part of your planning, should be part of what you're building and testing and everything, right? So we're going to talk about why we want to do that and then I'd like to show you a little bit about what that means in the enterprise perspective for a variety of your enterprise capabilities. So up front, why should enterprises embrace it? Well, the answer is so that you can get the benefits of DevOps without compromising security, right? So we've been talking a lot about DevOps over the last decade, especially, and there's a number of benefits that have come out of those kind of modern practices. And really what those are rapid, cost-effective delivery, right? So if we imagine our software as a value stream, right? Value being, my customers don't get any value when I plan my work, and they don't get any value when I code the work. They don't even get value when I test it. They really only get value once it's in production and available to them, right? So getting that flow quickly from ideation to deployment is so important, particularly so that they can get the value, but also so that we get this fast and constant feedback. Okay, how did our customers respond to that, right? How did our users respond to that change that we made? Well, if that time delay between when we came up with the idea and when we found out that it just wasn't a good idea, if that's a 6-month delay, oh man, we just lost a lot of time, right? So having reciprocal, fast, and constant feedback is one of the key principles of DevOps, and we shouldn't let security hold that back, right? Another benefit of DevOps with this perspective is that we're preventing security vulnerabilities. Now, we're going to talk about how we do that, but ultimately it's that we're going to integrate security into our development cycle so that they don't reach production and where they have to be discovered there. Now, we're still going to want to be prepared to discover them, out in the wild, but we're going to do our best to build security into our development lifecycle, into our pipeline and testing to prevent them from ever getting out there. We're also going to try to enable fast detection and response to potential security vulnerabilities or incidents, right? And part of that is going to be, we thought about those early on, so we already thought about, well, how would I detect if something went wrong with this? How would I respond? And I built that into the plan and the development, and it shipped at the same time. It didn't ship 2 months, 6 months, a year after that was live once we started thinking, what vulnerabilities might we have? No. I thought about that during the change that I made. And then some other benefits organizationally are that you're going to develop well-rounded engineers who have security knowledge. Why would I keep my security knowledge just in the minds of a few security experts, but then just expect my regular developers to not know anything about security? That seems foolish, doesn't it? So we're going to develop well-rounded engineers within our organization. And one of the ways that we're going to do that is by constantly creating individual knowledge by having those developers work with security people. And then as they discover things, when they kind of have that aha moment, or they learn, okay, this is how we're going to do something, or they learn from a mistake they made, we're going to try to spread those local discoveries into global improvements throughout the organization. And part of that is cultural. Rather than hiding our mistakes, we're going to kind of celebrate them and show that, hey, we learned something and everybody should learn from that. And then the last benefit I've got here is that this will help us attract and retain skilled engineers. And the bottom line is, great engineers expect this these days. So if you have a culture or, processes that don't enable this kind of work, the best engineers are going to shy away from that. And if you're a hiring manager, one of the things that you should know is that engineers spend time thinking about how they're going to interview you to determine whether or not you are doing these things, because they will reject you as their employer if you are not doing these things. So those are some of the key benefits, and we're going to talk about what this looks like, what this means, and I really welcome any of your questions about how this might challenge what you're currently doing. So I identified 7 key areas here where I'm seeing that this tends to challenge what enterprises are traditionally doing. So these are some of the things that they struggle with, and I want to talk about, what is this going to look like in a DevSecOps, a continuous security world, and how might you go about doing this? So the first one, and truly the most important one, is culture. I've got this quote on the screen here: "Culture eats strategy for breakfast." And people talk about that in a lot of different contexts, but DevOps and DevSecOps is really first about culture. Anybody who says that DevOps means that you've got a pipeline that's running automated tests, they're just not seeing the bigger picture. The bigger picture is that DevOps is trying to minimize the distance between the people doing the work, the people authorizing the work, and the people seeing it in action. Those really should all be tightly integrated, and that's why we're putting Dev with Ops all together. One of the things that comes out of this is that change approval processes that we traditionally have in an enterprise environment, what we've learned is that they can potentially have the opposite effect than we intended. They contribute to these long lead times where I, created a plan, I made a design, I submitted it to the architectural review board, right? And ultimately, I just got really weak and slow feedback through that process, much worse than if I just made a very small change, had some peer review, and learn from it right away. So change control failures often paradoxically strengthen the control and actually worsen the issue, right? So we go, let's through our processes, so we need even stronger processes. Well, it turns out that those extra steps and approvals lead to these increased batch sizes, where now, rather than being able to ship every week or month or something, we're going to say, we're only going to do quarterly deployments. Well, those batch sizes and long deployment lead times tend to be actually part of the problem that those issues were introduced in the first place. And in an enterprise environment, no one's ever really willing to remove control processes and procedures once they're established, right? I mean, think about the last time someone said, we don't need these approvals. Let's just remove them. No one ever wants to do it. It's only when the company falls under the weight of its own processes and somebody goes, I'm going to start a new leaner company without all that red tape, right? So sometimes it takes some courage to figure out, okay, we don't need this approval. We can do this a little bit differently. Let's see. Okay, so and one of the reasons is that in a DevOps culture, what we've learned is that people closest to the problem typically know the most about it, and that's especially true on complex and dynamic issues. So moving approvals closer to those people improves the likelihood of success, and moving it further from those people reduces the likelihood of success. One of the other things that you're going to see in a DevOps culture, a DevSecOps culture, is enabled peer review of changes. Now, many of us in the kind of GitHub world see peer review as a pull request or submitting a merge request of some code. And that's a fine way of working, but the early concept of continuous integration didn't really involve pull requests like that at all. It just involved pulling another developer to come look at your code, or maybe they're pair programming. They're working together, and so that review is continuous. Now, in a security environment, you might say, okay, I'm making a change to something significant. I'm making a change to the authentication flow for my website. And in that case, maybe that peer should be a security person who's reviewing my changes. And that's okay. And you may, as a policy, want to require something like that, and that's okay. But that review should be between peers and not necessarily, submission to an architectural review board where they're not really peers, right? There's some authority, some gatekeeper. That's where we learn that we get a lot of problems. And another element of DevOps and DevSecOps culture is a just culture, right? Where people are not afraid to, make mistakes. They're not, as long as what they're doing is in good faith. And this is really important because you want everybody to be trying to contribute. You don't want people afraid to make changes or propose things. And part of that goes along with rehearsing failures, being prepared for a failure and not seeing it as something that's shameful that you're going to sweep under the rug, but rather identifying, lessons learned out of it. And there's this concept of blameless postmortems that we talk about in DevSecOps, where we have some failure, and afterwards, we're not going to look for blame. We're going to look for what was the root cause. Because even if there was some mistake, okay, Steven, he made a change to the database that he shouldn't have made. Well, what can we do to prevent unapproved changes to the database? I mean, was that really Steven's problem? Or was there a root problem that we're allowing unfettered access to our production database, right? So let's take the blame off Steven. And then the other culture things here are converting local discoveries into global improvements, right? So we learn from something, and we're not afraid to put it in the Slack and say, we made this mistake. This is what it looked like. Here's how we fixed it. And let's all kind of talk about that for a second. One of the sources of this lesson came from assembly lines on vehicle manufacturing, where they had an andon cord at the Toyota factory, which was like this cord that you could pull that would stop the whole factory from doing its work. When they noticed something wrong, they didn't just continue working and hide it. They would pull that cord, stop everything, and then everybody would come over and learn, okay, this was the mistake. Well, that means that everybody learned it right then, and they don't all have to make the same mistake to learn it for themselves. That's something that we're trying to do with DevSecOps. And then the last one I've got here is empowering all our engineers to develop securely. And really, we don't want to tell developers, well, don't touch this, or you couldn't do that, or whatever, because those are involved with security. Instead, we should think about how can we empower them? Can we provide self-service security controls? Can we give them easy ways to do something? One of the common things that we see is developers hard code credentials into a Git repository or some sort of configuration item, because they don't have a better way of doing secrets management. Well, if you give them a clear path on how to manage secrets programmatically, they're going to choose that every time. There's really no reason for them to invent their own way to do that. So empower them to do that correctly. And then also just think about, what else can I do to empower them? Does that mean giving them hardened images for a virtual machine, template code, secure design patterns, or can I help build their pipeline to do automated testing and scanning, and things like that, so that they're not afraid to develop securely? So that's going to be part of the culture. And I would love, if you have any questions about what this culture looks like, go ahead and drop it in the question box, because I'd love to talk about it. I really think that culture is going to be the most important and most challenging part of any DevSecOps transformation. Okay, so let's talk about some of the other capabilities. Next is governance. One of the things that you should be doing is developing roles, responsibilities, policies, and processes, procedures, all these things that we're used to in the enterprise. And you should be thinking about how can we do this with a DevSecOps culture in line with our compliance requirements and our organizational, risk tolerance. So in some organizations, this might be much more relaxed than others. Facebook, for example, was known early on for their mantra of, move fast and break things. And so they had very little governance, and that persisted for a long time. Now, I think we've all learned a little bit of why that didn't go well, right? They had all these things that worked out pretty negatively, but that kind of culture probably doesn't work in healthcare, right? If you've got HIPAA regulation and you're dealing with sensitive health records, maybe you shouldn't just go fast and break things. But there's some balance, and depending on the components of your workloads, you would be surprised that more things can be, delegated and more relaxed than we tend to think, as long as you've got the right culture and, you're hiring mature people and you build the culture where people aren't being irresponsible with security. So one of the questions that you'll ask in this process is, what benefits from centralization and what can be delegated, right? There's some things that can be centralized, and then I can provide that as a service to many of my teams. What decisions do I absolutely need approval on, but what maybe doesn't, right? Like, how much change can we just allow through peer review where, we should ask people to stamp their names on their changes. That's one of the great things about, code and, Git workflows. So people should be accountable for the changes that they make, but maybe we don't need to have that all go through an architectural review board. One of the things you're going to ask at the governance stage is, how are we going to assess our risks? Because there's still going to be risks, and we may have less perceived control over them if we shift our security left and have less checks at the end. But we can still manage our risk, and we can still assess our risk. And so we want to think about, how are we going to do that? And then there's a lot of other things that you could give very clear guidance on that I think you'll find to be much more helpful than requiring certain things. So, data classification. Nobody wants to invent their own data classification scheme if they can avoid it, right? So depending on your organization, give them a clear definition of, hey, here's how you should handle your data, right? Lifecycle management. Hey, here's how long I want you to keep data, and here's how I want you to do that in these environments. That's one of the easy things to do to minimize your risk, so that you don't have data sitting around for 10 years or longer because nobody felt confident that they could put a lifecycle policy on it and have it automatically deleted after 3 years, right? But in reality, if you don't have that data, then you don't have to secure it, and you don't have to have some auditor find it, later. So giving clear guidance on things like this, and just generally figuring out what does my governance look like in my organization, that will go a long way. Okay, so let's talk about identity and access management. This is another tricky one. We're asking in a DevSecOps world, we are asking to empower our engineers as much as possible. But as security people, we're always thinking about the least privilege principle. We don't want to give them more power than they need to do their job, right? So here are some of the ways that you can do that and what it looks like. One is enable use of a centralized identity provider wherever possible, right? And through that identity provider, enforce your MFA. There may be exceptions where this isn't possible, but I would go so far as to say you'd be surprised how far you can take this, even on the command line. So, for example, in AWS, you could use AWS SSO, and that works for authenticating on the command line with your MFA, providing just temporary tokens to your developers. So they don't need to have an IAM user that has these persistent credentials that are such a risk if someone were to get access to that laptop and now they've got these persistent credentials to impersonate your developer. That's one of the ways that you can just reduce that risk. And then think about what you can do from a centralized perspective where you're setting strong permissions boundaries, but allowing reasonably broad permissions. So one of the best ways to do this is by segmenting your environment. So I know this isn't supposed to all be about cloud, but that's where most of us are building these days, right? So if you can segment your cloud environment, then you can give your developers reasonably broad permissions within that, and they're only within their account, their AWS account or their Google Cloud project, and they're not messing with other workloads. But I still think it's really important to have, some boundaries and policies that are prohibiting things that you just don't think anybody in your environment is going to do, whether that's use unapproved regions, outside your country, or use some of the most expensive things, or things that you really just don't think regular developers are going to do. You can centrally manage those. And then the other one is frequently audit your permissions and scope them down, remove things that aren't necessary, especially to production environments. I mean, that might apply to development environments as well, but especially to production environments. A lot of times when we get started, we have broader permissions because we need to make things work, and we don't want to mess with fiddling our permissions down. But once things have gotten up and we're mostly stable, it's time to go back and re-review those policies. And there are some tools that can help you do that. Each cloud provider has some tools to do that. AWS has a great one where it'll go through all your CloudTrail logs and say, it'll build you a policy based on, what you've used in the last 30 days and say, that's all you need, right? That's all you've been using. So that's just a really powerful way of limiting the possibilities of compromise of those credentials. Okay, another part of shift left security here, or continuous security, is that you should have threat detection as much as possible, in every system that you've got. And part of this is that the security trends these days is to imagine that you have a compromise, right? And you're hunting for that potential compromise at any given time. So you should be ingesting your monitoring logs and information into some sort of central system, a security information and event management SIM for correlation. And in a shift left environment, you want to give your application delivery teams easy pre-approved ways to do this, right? If they're shipping some new VMs, they shouldn't need to think about, hey, how am I going to instrument this VM to get into the SIM? Give them an easy way to do that. That might include, a base image that already has it built in, or whatever it is. But there's different ways that you can do that for your systems. And think more than just the VM, but also how am I going to get my new AWS account integrated into guard duty, which is performing threat detection, and have those guard duty logs shipped off to my SIM. And does that require, can that be fully automated? I mean, depending on your tools, it probably can be, right? So every time a new account is created, a guard duty detector is created and integrated into the rest of my system. And now nobody has to worry about that. And then the other part of this, and I feel like this is often forgotten, is give your delivery teams access to view these logs for their daily troubleshooting, right? There's a couple of reasons for this. One is that, that's actually really useful, right? Sometimes they need to go, okay, who did this, or what actions were taken, or why was this request denied, or, what parameters did I use for this, right? Let them view those logs right there in that system. So that will help them with their daily work. But the other part of this is if there's an incident and it comes time to investigate, they know how to use that system. They know what those logs look like, and they would be able to identify anomalies and help you assess the impact. Oh, yeah, I see that this attacker got these credentials and they performed these actions, and I know what those actions look like because I do them on a daily basis. They're just abusing them, right? So enabling that team to help you in threat detection is so much more powerful than saying, well, our SOC is going to handle it and they're security guys. Well, how could they possibly know every possible technology that you've got in your enterprise and all the environmental, context of it? And just like, how could they possibly know all of that, right? So they can help, but being able to use those teams during threat detection will be super helpful. Okay. Vulnerability management is this next topic. So we're going to talk about vulnerability management as continuously identifying, classifying, and remediating and mitigating your security vulnerabilities. Now that sounds very broad, but this is going to depend on what your workloads look like. But I'm going to encourage you to combine both passive and active techniques to doing this, because neither one is very complete, but together you'll feel much more comfortable that you've got a comprehensive management program. So on the passive side, we're talking about employing vulnerability scanners, endpoint agents, and those can be super helpful. So in the cloud, we talk about cloud security posture management tools that are kind of continuously scanning your configurations. And you can set your own policies in those based on your context. But they can also just identify really obvious, vulnerabilities that you've got. And that can be super helpful, especially if you're able to do it to a pre-production environment, right? So you may have an AWS account that represents, a staging environment, and you make changes there before it goes to your production environment. Well, let your cloud security posture management tool look at your staging environment, right? If it finds something wrong there, then you can identify it before it gets to production, where your real data is stored and is at risk. And then on the active side, this is the kind of stuff that gets security engineers out of bed in the morning. Like, let them red team and penetration test your environment to identify vulnerabilities. Challenge them to find the flaws in your system. And if you don't have a team that can do that, partner with somebody who can. This stuff is the kind of the key of what my current company does at ScaleSec, where we can help you identify these issues, set up these capabilities, and coordinate with penetration testers. Because this isn't something that you're going to want to do in-house if that's not your expertise. But together, active and passive vulnerability management can be very successful. Application security is the next topic here. So here we want to empower our teams to deliver code in small chunks with confidence. And that's really the essence of it. So there's a lot of techniques to think about when it comes to application security, and this is something where your security people can integrate with your developers. So they can build unit tests that are not just about the functional features of your application, but are also verifying security-sensitive operations, right? So if it's an authentication flow, I want to make sure not only am I having a successful login, but also successful, denial of inappropriate logins, right? And making sure that we've got unit tests that if somebody makes a change, there's no way that we accidentally opened up our authentication flow, right? So that's just simple unit testing. But we can also integrate automated security analysis to identify common issues. And actually, this is what most people think of when they think of DevSecOps, is they think of, we've got a pipeline with some automated scanners doing either static and or dynamic analysis. But really, as we've seen, DevSecOps is much broader than that, but still, this is one of the key elements of it. So when we talk about static and dynamic analysis, let's talk about some of the differences and their advantages and disadvantages for a second. Static analysis has kind of white box visibility, meaning it can see into your code, and it is a very thorough approach. It can also be very cost efficient to identify and detect bugs in a very early stage of your development cycle. So that could be really helpful. And it may also unearth errors that wouldn't have emerged in a dynamic test. So that can be very cost effective, right? It's got access to your source code, and it knows about all the flaws in Java or whatever your language is, and it'll let you know right away. In fact, sometimes this can be integrated right into your developer's IDE, their development environment, so that before they even made a commit with that, they detected it right away on their local machine, and that's ideal. That's super fast, right? Dynamic analysis, on the other hand, can expose subtle flaws or vulnerabilities that are just too complicated for static analysis to reveal. But it's only going to find defects in a part of the code that's actually executed, if that makes sense, because that's running in a more black box methodology. So together, enterprises should weigh up these considerations with their situation and determine what's appropriate for them. Modern application security analysis tools will do a lot of these things together. They will do composition analysis to look at the dependencies that your application is pulling from and making sure that those don't have known flaws. They can also do container scanning to scan the container configurations, which many DevSecOps teams are using containers, but want to be sure that they're doing that appropriately. So automated security analysis can really help you identify these common issues. But culturally, an important part of shift left here is that your engineers retain responsibility for the security of their code. So they don't get to ship this off to some other security guy to have him scan their code for problems. They should be doing that as part of their daily work so that they learn right away, oh, hey, I wrote something that was insecure. So, yeah. All right. And then the next topic we've got here, or I guess this is our last one for today, is incident response. Now, this is one of my favorite quotes ever from Dwight Eisenhower, saying, "In preparing for battle, I have always found that plans are useless, but planning is indispensable." And this rings very true when it comes to incident response. Your specific plans may not capture exactly what a hypothetical attacker is going to do, but the planning for thinking through what they might do and how you might harden your system is truly indispensable. So thinking through what are our potential threat scenarios, what is most likely to happen? What are the most likely courses of action that could happen here, right? And maybe those most likely courses of action aren't too significant, but still we should close those up, right? But what is the most dangerous thing? I mean, maybe this takes a bit of a more less common mistake or error to happen, but what would its impact be, right? How would we know? How would we know that this happened, and how would we respond, right? Who would respond to this? In which environments? Because we probably aren't going to have the same responders who know everything about every environment. So how would we coordinate that? What if they took down our communication channels? How would we communicate, right? So if if you're compromised on your primary communication channel, where would you go next, right? How will we communicate to each other? How will we communicate to our customers and our service providers? We've seen recently some examples of really bad incident response to security flaws that really damaged reputations of companies, specifically because they may have just denied that there was one in the first place. And then little by little, it turns out there was more and more and more. And that damage is done if you're not communicating to your customers effectively. And so you should have that planned out. And then also coordinating with your service providers. Your cloud service providers are likely to be very interested in helping you in the event of a serious incident. AWS, for example, if you have their AWS Shield Advanced service for denial of service protection, like they will jump on with you and block denial of service attacks and really help you coordinate that response. If you have support from your cloud providers, they want to know, they want to pull in their experts to help you, but you need to have a plan for how you're going to contact them and coordinate with them in the event of an incident. That's not something that you want to be figuring out on the fly, Googling, how do I contact Google for help about my security incident, right? That's not something you want to be figuring out. And then also, how are we going to let incident responders into our environment, but then secure those credentials, right? So we've got some break glass credentials that we only use in the event of an incident, because potentially our Active Directory has been compromised, and so our normal federated authentication flow is not available, and now we're locked out of our environment. But luckily, we've got these break glass credentials that we can use in the event of an incident. So we want to be prepared for that. Okay, so I'm excited to get to questions, but quickly, our summary of why enterprises should embrace shift left security. It's to attain all the benefits of DevOps that we've talked about today without compromising security and really improving security. Rapid, cost-effective delivery of your software, preventing your security vulnerabilities, enabling fast detection and response to potential incidents, developing and attracting and retaining our well-rounded, skilled engineers to work in a security-conscious environment. Done correctly, this is a very effective way to ship software securely and maintain that while getting the business agility that comes along with DevOps. So that's what I've got, and I'm going to look at my question box here and start answering what you've got. Let's see. One question from Tom I see here is, what auditing tools do you recommend to use other than the native offerings? So my answer, Tom, is I do like the native offerings that cloud providers have. Honestly, AWS Guard Duty, for example, as a threat detection service, it's like so much more powerful than it seems, because AWS has integrated their threat intelligence into that product, and they're doing a lot of secret sauce behind the scenes that you can't see, that other providers just wouldn't be able to do as effectively. So I just want to say that I am a fan of the native offerings, but depending on your enterprise, that may not be a great fit for unified visibility, for example. So, a common one that we're seeing is Palo Alto's Prisma Cloud, so that, an enterprise can have a Google Cloud environment in there as well as their AWS environment, for example, and those are very effective. I don't want to point out a ton of vendor names, but I think you should do some evaluations and see what's right for you. And so, yeah, there's also some open source tools. Like if you want to get started, again, I bias towards cloud and AWS, but there's tools out there for scanning your AWS environments like Prowler or Cloudsploit that can be very effective at at finding the simple things. And as a cloud security consultant, we use those. to kind of get the obvious stuff. But then we really like to dig deeper and, use that as a discovery to dig deeper to really understand, what you've got and what the best way to secure it is. So hopefully that answers your question, Tom. Paolo asks, we talked about segmentation of environments. How do you do that and manage costs at the same time? That's a good question. So let's talk about, again, I'm leaning towards AWS here, as that's what I have the most knowledge of. So AWS, now recommends multi-account structures as the strongest, segmentation boundary system, right? So I've got an account that's just for, production of a particular workload. And I probably got another one for pre-production of that workload that is hopefully very, very similar. How do I manage costs of that? So there's a couple of things. One is, in the cloud, networking costs is a major issue, right? If I'm flowing data back and forth too much, I'm going to incur a bunch of, data costs. So one of the things to do is just minimize unnecessary data flows as much as possible, and potentially architect, hub and spoke networks that let you move data through some, central point, without everything having to go across the internet where it's going to be more expensive. So that's really going to be, dependent on your workloads, but networking cost is one thing. And then the other one is, the workload cost. And how do we do that is the most powerful way to do that is to leverage serverless technologies, right? So that's just going to minimize your costs in general, but especially if I can spin up a serverless environment, and then tear it down 20 minutes later, and I only was charged for the requests that I had during that time, or maybe I leave it up all day, but I'm only being charged for the requests that I'm handling. Your costs are just going to be so much less than they would be if you had to spin up big virtual machine instances to do that. So I'm a huge fan of using technologies like AWS Lambda, step functions, DynamoDB, right? These serverless technologies where I'm only paying for what I use in the cloud, and especially if I'm very cost conscious. Now, people will argue about serverless all day, and I'm not here to take a side too strongly, but definitely if cost is a major concern, especially if you're a startup and and you don't need to burn your runway on giant virtual machines, I think serverless is definitely the way to go. If you later determine that your particular workload would benefit from having a virtual machine on all the time, and you go, okay, this is a consistent workload. I know, I'm getting constant requests, and I just really want optimized request response times, whatever it is, right? Then maybe you can lift that up and put it into a virtual machine. From my perspective, if you initially wrote that workload as a collection of Lambda functions and an API gateway, it's going to be a lot easier to refactor that and drop it onto a VM because you've already got clear, segmented, modular code. It's going to be a lot easier to do that than trying to do the reverse, where you wrote some giant monolith in Ruby and now you're trying to refactor it to run on serverless stuff because it turns out that you don't need it that much, or it's traffic patterns are really spiky and inconsistent. And so, this would really benefit from Lambda. So that's hopefully that's not too much, but that's my long-winded answer. Edward asks, what are you using to check new code to eliminate security flaws, potentially. So what am I using to check new code? I mean, there's a variety of tools out there. I don't want to give any particular vendors too much of a leg up when it comes to that. But I think for the most part, most of the top vendors in application security scanning are doing a really good job. And if you're using, you should find one that specializes in whatever your language and framework is. Not necessarily specializes, but somebody who a vendor that knows that very well. And I think that if you do that and if you do it conscientiously, I think you're going to have a lot of success eliminating application security stuff. And actually, since it's fresh in my mind, we were just talking about Lambda and serverless. A colleague of mine at ScaleSec just wrote a really great blog post about application security where we talked about there's this kind of perception that serverless technologies are going to be secure by default, right? And it's true, they're much more secure than having to run my whole VM because in Lambda, I'm only really responsible for my code. Everything else is the responsibility of my cloud provider. But that doesn't mean I have no responsibility. And so there's a lot of ways that we should still be thinking about how to write secure code to make sure that my inputs are sanitized and I'm not letting somebody take over my execution environment, even if that execution environment is tightly controlled. So it's definitely still a topic, and if you've got further questions, I'd love to answer them. Looks like we're running low on time. Any other questions?
Nope, it looks like that's it.
All right.
Yeah. Thanks so much for the great presentation, Stephen.
You're very welcome. Feel free to reach out to me anytime. I'm happy to, take these conversations to another venue if you'd like.
Okay, great. Yeah, I think everybody has your contact info. If not, you can find it in the slide deck. Everyone stay tuned. We're going to take a short break and be back at the top of the hour for our second session of the day, DevSecOps and the new Dev Security Landscape best practices. Also, please refresh your browser to access newly added resources on your console provided by VMware Tanzu. We'll be right back.
Thank you. Hello, everybody. Welcome back. Thank you for being here. Thank you to our speakers and fellow moderators, and of course to our sponsor today, VMware Tanzu, for underwriting this summit and allowing us to bring you this great content. I'm Gladys Rama. I'm the editorial director here at Converge 360, and I'm here to moderate the second session of our Application Security and DevOps for Enterprises Summit. This particular session is called DevSecOps and the new Dev Security Landscape Best Practices. Our speaker for this session is Carlos Rivas, Senior Solutions Architect. Carlos is an AWS infrastructure expert, As an independent cloud computing consultant, he helps California community colleges move their traditional data centers and applications to the cloud. Over the course of his career, he's worked for several large telecommunication providers, managing and configuring network devices using numerous tools and languages, including Java, Groovy, Python, Perl, and PHP. Carlos, take it away.
Thank you so much for that wonderful introduction. And hello, everybody. Good morning, good afternoon, or good evening, depending on where you are. I'm really happy to share this session with you today, mainly because this is really literally what I do for a living. Anything to do with application security, DevOps, and cloud is what I get to see on a daily basis. So it's really a passionate topic for me. And you can see I have my LinkedIn there on screen, so feel free to contact me if you have questions. I'm more than happy to help you with questions around this particular topic. In fact, just this morning, I got a question from a customer asking me, I have these containers that need to go to a web server. They need to be built on GitHub using GitHub Actions and things like that. And I just had a huge smile because, it's a conversation basically along the exact same lines of what we're going to be talking about here today, which is mainly DevOps. However, we're going to put a little spin on it and call it DevSecOps, mainly because security, right? Especially in my position, I'm a consultant, and you never want to put your customer in a position where you have some public-facing GitHub repository with their confidential information out there, or like a web server with a public IP with a known vulnerability exposed to the world. Those little details make DevOps, well, as we know it as DevSecOps. It was essentially just putting security first, or putting security as a built-in component of the whole DevOps landscape. So we're going to start our conversation talking about application security. Like I said, I just had a question this morning about it, so it's kind of fresh in my mind. We're going to talk about DevOps and how it relates to infrastructure and software architecture. At the end, we're going to have our usual Q&A, so feel free to bring in your questions. I'm more than happy to help in any way that I can. And with that, let's go ahead and move to application security. I always like to start from the bottom up. In this case, we're going to talk about microservices, which is essentially pretty much the most talked about software architecture out there right now. I heard Stephen talking about Lambda functions in the previous session and serverless technologies. Well, if you think about it, a Lambda function or serverless function is essentially a microservice. It's a little piece of code that provides a business function for you and your business. That's essentially what it is. There's nothing else to it. However, how do we spin that up into a world of DevOps and DevSecOps? Well, we're going to get there. First, let's go ahead and talk about, what exactly is a microservice. It's essentially a service-oriented architecture, and you have a series of loosely coupled components. In other words, there's no super interdependency, like if one crashes, everything else crashes. This is not the thing when we're talking about microservice. It's like little components that use messaging queues and other ways to communicate with one another. All right? So that's something to keep in mind when actually building them. You don't want to have like super dependencies across the board, this authentication service depends on something in the back end that, if that thing crashes, this one crashes. No, you have to consider microservices as independent units that, yes, of course, you're going to get an error message saying, hey, database not available or something like that, but your service itself should be designed to handle those other services being unavailable. It's just part of the whole architecture thing. It's if you ask around Amazon, how is Amazon Web Services designed overall, is designed in a way that you have to assume every single service is going to fail and other services are going to wait until the recovery happens. That's something that you need to keep in mind when designing your own software architecture as well. So this is an example of what it will look like to have a bunch of microservices talking to one another. On the left, you have, let's say, a mobile client or a user visiting your website or something like that. Obviously, before allowing them to use your entire microservice landscape, you would need to get them through some sort of authorization and authentication. So let's find out if they are who they say they are. And at the same time, we also need to find out what permissions do they have, okay? And for that, you have an authorization server or a credential server, something that you can use to authenticate this person. I'll tell you right now, usually it's a really bad idea to try to code that yourself. Fortunately for us developers, there's tons and tons of services out there that provide this authentication and authorization mechanism that you can just use right out of the box. So if you're creating a microservice today, you can have the authorization and authentication part done today. You don't need to wait for that. And that goes not only for AWS, that's the same for Microsoft Azure, Google Cloud, any other providers, Firebase, things like that. There's all kinds of tools out there that allow you to get this part taken care of. And sure enough, they also use a microservice architecture in their backend for this type of stuff. Now, let's say that you have your user authenticated, right? You would get some authentication ID. In this case, is a JWT or a JSON Web Token. And you can use this token to pass it to your microservices and say, hey, this person is actually authenticated, and these are the permissions that they have. And, of course, your microservices will validate that token with the authorization server, right? They don't need to know the user's details or passwords or anything like that. They just need to know that this person is literally has a valid authenticated session. And of course, going back to the loosely coupled concept, you have inventory, you have accounting, shipping, all those things can go offline, and that's okay. If those things fail or crash or whatever, it doesn't need to affect the others. Yes, you may have a situation where you can't make a sale because the inventory microservice is out of commission. But of course, that's why we have DevOps and all kinds of monitoring mechanisms to bring that back online as soon as possible. Just a little thing to keep in mind, the overall architecture. Because this is, if you're a software developer or just getting started in the cloud space, this is the most popular architecture you'll see out there, whether you're using AWS Lambda or just traditional microservices that run on Tomcat web server or Node.js or something like that. Regardless, this is where you're going to end up, in an architecture that looks more or less just like this. Now, moving on to dependency management. So when you're developing software, chances are you're never, ever going to start writing everything from scratch. That will take you too long, and by the time you are done, you're going to have a bunch of vulnerabilities in your code, things that you may have overlooked, and your competitors will be way ahead of you because they're actually using libraries that already exist and take care of all this stuff, right? Now, when you're managing dependencies, the problem is these are external libraries that you're bringing to build your application stack. And these external libraries, of course, they're constantly under development, and they're usually open source or something like that. They're exposed to the world. So if they have a weakness in them, hackers will know about this weakness and will, of course, do their best to exploit this particular set of weaknesses, okay? Just something to keep in mind when you're downloading stuff and you plan to use it on your public-facing web applications. Just know that these libraries can expose you to security weaknesses. Now, in this case, I would like to recommend a tool called Dependabot, and it's just a little feature, and it's part of GitHub, okay? What Dependabot does is it will take your list of dependencies. We're talking about your requirements text file if you're a Python developer, your JSON file, package JSON file if you're a Node.js developer. So things like that. Your composer, I believe, is called if you're a PHP developer. And these files contain the list of dependencies that you're going to use. What this software does is, behind the scenes, it will look at your list of dependencies. And from there, it will determine, okay, you're using this version of this software, but there is a newer version that takes care of a critical patch. Let me go ahead and help you update this thing. And it will create a pull request into your GitHub repository that you can use to automatically update your requirements dependencies for your application. So this is something really handy. You don't have to worry about it. Just use whatever you use, and this will help you with the updates. Of course, if you're into, let's say, 6 months into a software development project, and you just randomly change a library, you could break your own code by simply running an update, right? So just keep that in mind. However, this tool is not going to force update your code. What it's going to do is create a pull request and it will give you the opportunity for you to evaluate this potential change instead of just randomly making the change without, you knowing about it. This is more or less the architecture, what it looks like. It will, run an update checker, looking for whatever it is that you're using. It will update your requirements or package file, and it will tell you, hey, there's a, you're using 4.5 version of this package. Now there's 4.6. Would you like to do this update? And if we're talking about a minor update, you just go ahead and do it, and you don't have to worry about that. I'll give you an example from my work, my everyday work. AWS CDK, or Cloud Development Kit, man, that thing, they just run those updates like all the time. It's like pretty much twice a week you'll get an update. So it can get annoying at some point. So it's good to have a tool that will monitor and making sure that you have the latest. But of course, like I said, this is mainly for all those AWS CDKs is a bad example because you would like to assume that the provider in this case has security practices and they're not going to push code that is dangerous. But, we like to use packages that are out there on the internet, and sometimes, they may not be the most secure to use in our applications. So it's good to know that something like this has your back, and you can use it to keep your packages updated. Right? Now, I just briefly touch on user authentication when I mentioned JSON Web Token. Let's dive a little deeper into this thing because this is so important. Not only for the end user of the application, but also for the users of your environment. I'm talking about your database administrators, your system administrators, even your application developer. Everybody needs a set of permissions and access into your environment. So user authentication is always going to be on top of mind here when it comes to application development and DevOps, right? So getting into this is going to be the architecture that you'll see the most, whether you're using, Active Directory or AWS Single Sign-On or any other mechanism to manage access. This is more or less what it's going to look like. You're going to have an end user that comes from a mobile phone or a desktop client or a web browser, and they're going to send in a request. Your authorization mechanism is going to either deny or grant access to this person. And then your authorization mechanism is going to gather, what is the role of this person? Is this a developer? Is this a database administrator? Who is this person? And let's gather the necessary permissions for this person and just collect that into a document. And then this document can be used by the rest of your microservices or services in general to allow or deny certain features to this particular person. So it's going to look like this. Most of the time, they're going to send in a request. They're going to get a token back. Once they have this token, then that remains valid for the remainder of their particular uses session in your application. What I use in this case, or what I recommend, if I'm inside AWS, which is my go-to environment on a daily basis, I would recommend AWS Amplify because it has integration with Amazon Cognito. And this is what I would use. If I was developing an application right now, microservices or anything, it would probably use Cognito. And you can implement that using AWS Amplify fairly easy. Not only that, it also contains support for social logins, meaning that instead of having the user have to remember another set of credentials, you can just provide a button that says log in with your Facebook, log in with your Google ID and things like that, so that they don't need to think about any more credentials. They can just use that as their SSO provider. Arguably, you can probably say the same thing about Auth0 and Firebase. They're really solid providers when it comes to authentication. They've been in use for years. And one thing that I recommend is that whatever you do, even if you don't use any of these three, is do not try to implement security by yourself. It's best to have a dedicated service that you pay or somehow integrate into your application, because this is probably the most delicate part of your application, right? You don't want to mess this one up by trying to do this from scratch, because if you mess this one up, you're exposing your application and your customers to a potential data breach. So even if you don't use any of these three, just be sure to use something that is done by a dedicated team that just specializes on this type of stuff, like security and authentication and authorization mechanism. Because if you do it by yourself, you're like super likely to miss something. And you might think, well, it's super easy. I just need to put a form out there that says login and password and forget your password or something like that, and that's it. It's really not that simple. There's a lot that goes on in the back end of these applications to make login and authorization possible. So highly recommend that you use one of these or whatever other solution. Say Okta, for example, is really, really good. So yeah, you can use all of those and have them built in your applications. Now, more specifics about DevOps, because those things I just mentioned are more oriented towards, application development. This is more internal for building the application itself when it comes to DevOps. So you have managing credentials. Let's talk about that for a second. So you have secrets, and secrets are always going to be present in your application. Let's say a microservice. A microservice is going to need some API token. It's going to need some SSH key. You're going to need some kind of sensitive data, and you don't want that data just being all over the place or being stored in a non-sensitive, non-encrypted environment. You never want that. So here comes the question. Let's say that you have a microservice that you just developed, and this microservice is going to be promoted to your test environment. From the test environment, it's going to be promoted to the production environment once everything clears. Now, as it goes from dev to test to prod, during this time, it's using various secrets, like passwords for database or, user authentication mechanism. So you never want to be that guy that hard codes any kind of information like that inside the microservice. Never do that. That's probably the number one rule in DevOps and DevSecOps. Never store credentials in your code or in your repository or, in your microservice itself and the binary that you generate. So what do you do in this case? You have several tools. Right now, one that comes to mind is GitHub Secrets. I really need to update this slide for that reason, because now these days I'm using more GitHub Secrets to store sensitive data, because it's really an encrypted storage that you can use as part of the whole GitHub setup, and allows you to integrate that with GitHub Actions to build your containers and pull the data from that sensitive storage, right? I'm showing on screen HashiCorp Vault, which is also an open source solution by HashiCorp. And essentially, it does the same thing. You can use it to send a query to this vault, and it will, go in there, decrypt data, get whatever you need, whether it's tokens, passwords, and all that stuff. You will have it stored there and just pull it when you need it. A feature that I really like about this particular software is that you can create temporary AWS credentials. So you can send a request and get a temporary cloud credential that you can use to build something, push a container, spin up a Windows server or a Linux server, and get your stuff done. And then those credentials will be discarded. They will be thrown away. And, that's a really good peace of mind, knowing that your container or your DevOps mechanism doesn't have valid credentials when it's just sitting there doing nothing. So if your DevOps backend gets hacked or whatever, they're not going to be able to pull anything sensitive out of it, because it has to be running. When it's running, it's when it will go ahead and pull credentials, do its thing, and then discard the credentials. So that's one little feature that I recommend about this particular software. More or less, this is the recommended setup when using a secrets manager. By the way, Amazon also has a parameter store and a particular secrets manager that you can use. Probably every single cloud provider now is integrating that into their own feature set. But anyways, this is what it's going to look like when you're out there. You see all these boxes in red that says App Secrets, and there's one that says App Secrets in blue here. And the goal here is you don't want to hard code any of this stuff along the way, whether your repository or your build environment or your registries or artifact repositories. What you want is what we call just-in-time authentication. So let's say that your application is ready to run in dev or in test or in prod. All it needs to know is the name of the environment, which is going to be, you can pass it in a environment variable. And once it knows the name of the environment, it will send a request to the secrets manager, in this case, HashiCorp Vault or GitHub Secrets. And at that time, the data will be pulled into the container in the form of environment variables. So you have a variable that is called DB password or, DB username, which are your credentials for your database. And at that time, it will go to that repository or sensitive repository, whether it's Secrets or HashiCorp Vault or whatever, and it will pull that data at that time. So when it's time to do its thing. So this is really what I'm telling you with these slides. Never store your secrets in the repository itself or as part of your CI process or let alone the craziest thing would be to actually build it in your binary register, whether it's Artifactory or Docker registry or something like that. You want to be able to dynamically inject that when you need it for your containers, right? And when I say containers, of course, I'm talking about the whole microservice architecture, okay? As I mentioned, you can use HashiCorp Vault. You can use AWS Secrets Manager to do this. There's also a Strongbox. Docker has its own Docker Secrets now. If you're a Microsoft guy, you have Microsoft Key Vault. So you have certain just-in-time options to do this. One that is not listed here that I also recommend is GitHub Secrets, if you're a fan of GitHub Actions as part of your DevOps and CI process. Moving on from here, let's talk about scans. Scanning really is just taking your containers once they're built and making sure that they're not exposing you and your customer to something that is insecure. It's essentially the same thing that I mentioned earlier about Dependabot, but this is not as specific to packages. This is just as specific to Docker images. Let's take WordPress, for example, which is the single most popular web software used in the entire world. When you have WordPress is essentially a PHP software that runs with the MySQL backend, and you can add plugins and themes and things like that to it to create your own blog or website. Now, the thing about that is that it goes back to the same thing. You're pulling in packages from everywhere, using a ton of open source stuff to build your application. So there are certain versions out there of WordPress that are going to be, quite dangerous because they may have a vulnerability that allows injection or, something to be passed through that will break the site or, provide credentials to hackers. You may not be aware of all this at all times, but if you have some sort of vulnerability scanner, you'll be able to detect that. Essentially, a scanner is just taking your Docker image or your Docker file, which is what you use to build your application, and then from there, it will say, okay, we're using this version of the software or that version of the software. Let's find out what's going on over here and make sure that none of these versions are listed as part of the CVE database of known vulnerabilities, which, as you know, that thing is changing all the time. It's essentially on a daily basis these days, you have some sort of new vulnerability found that can be exploited. So you have to be on top of your game when it comes to scanning and knowing the versions that you use of any one particular software. Now, the architecture of a scanner, it would be something like this. Before I get into this, I'd like to say that I recently learned that AWS ECR, it's not super new, but they're also providing built-in scanning as part of AWS offering. So if you store your built images in the ECR registry or Elastic Container Registry in AWS, you can just enable a feature and they'll do scanning for you. So you don't have to really worry too much about this. But the process in general, whether you use AWS or not, is going to look something like this. You push your image to your registry, whatever it may be, and that will be the trigger for a scanner to run. You can do this, on a daily basis, on every push. You can do it once a week, whatever it's better for your development or CI process. And the scanner will run, as I mentioned, and it will validate what you have against the CVE database, or the most popular databases out there of non-vulnerabilities for software. And if it finds anything that matches what you're using, you will definitely get an alert saying, hey, you better look at this, or maybe upgrade this version because there's a new patch, or just not use this version at all because it's a 0-day type of situation where you don't want to be exposing yourself and your customers to this particular situation. And by the way, that's also something that happens to us developers. We want to use the latest and greatest out of everything. And that's also very dangerous because even the biggest companies out there, Apple, Microsoft, Google, if they put a software out there today, well, if they're putting it out today, it sounds great. You're going to get the latest features, but you're also exposing yourself to the latest weaknesses. I believe the audience in this particular presentation is not the kind of audience that will just go for the latest without checking for vulnerabilities first. You want to make sure you're at least one version behind or something to make sure that everything that needed to be patched is already patched. Because as you know, people just want to be first to market, and that exposes software to potential issues out there like weaknesses and potential data breaches. So just something to keep in mind. So these scanners are certainly very useful if you're creating microservices using the latest and greatest, right? Now, what can I do if I don't use AWS or Azure or something like that? Well, you can get particular scanning tools for your containers. Here's a few that I found that are kind of open source. You have Falco, Docker Bench, Dacta. Those things are out there, and you can use those as part of your CI/CD process. I also mentioned here Wireshark. If you are paranoid about your network, let's say that you have a lot of networking components exposed to the world, you want to use a tool like Wireshark to, just do scans here and there, make sure your ports are where they need to go, the data running through your network is where it needs to be. In AWS, this will be called flow logs, where you can use a tool like that to monitor what's going on in your network and trying to find anomalies, right? So it's in the same theme of scanning, right? The same thing goes for the actual application that you're deploying, the microservice. You can use an actual application scanner, something that will make sure that your application is on point. But if you're a developer, you probably already have some kind of testing software, some automated web browser that can fire up your own application and look for weaknesses and potential issues. That should be, like I said, if you're a developer, you should have that as part of your CI process. If you're using AWS Amplify, they actually have a built-in testing mechanism, and they actually collect screenshots and everything like that just to make sure that your website looks the way you expect it to. So yeah, just use the scanners in general to make sure everything is fine on your end. Now, encryption, it's usually a part of every single conversation I have with you guys. There's no way to avoid this. This is probably the number one thing. And I think it's hilarious because the other day I was doing a deployment for a new customer, and I got an email from Amazon because I work with Amazon a lot. We usually work in tandem to provide services to customers. And the message that I got from Amazon was, hey, you forgot to encrypt the storage units for this particular server. So like, whoops, I guess I'll fix it right now. Good thing that in Amazon you can, even though you created a drive and attach it to a computer, you can still do a an after-the-fact encryption and reattach the drive to the computer. But this is not something that I should be forgetting, or any of you for that matter. This is a really, really important part of the conversation. And when I say encryption, I'm talking about two kinds of encryptions here. The one that happens at rest, where you just have a secure key and your data, whether it's in your database, on your Linux servers or whatever, it's stored encrypted. But I'm also talking about the old super famous SSL certificates that you use to encrypt in transit, right? The reason about doing this is because, most people, especially when they're traveling, they'll just jump in anything that sounds like a free Wi-Fi, and they'll do their work. And in some cases, that's okay, especially if you have, let's say, a VPN. So in theory, you're encrypted along the way, so you don't have to worry about that. But yeah, you want to provide a mechanism so that you are covered and your data in transit cannot be, intercepted with a man-in-the-middle attack or anything like that. And you do that using SSL certificates and TLS in-transit encryption. So just something to keep in mind, especially if you are out there facing the public with a web server or something like that, like the WordPress that we mentioned before, right? One way to get the TLS, I believe Let's Encrypt, it's a free service, if I recall correctly. So there's no excuse about, not having in-transit encryption. You can just get that. Amazon certificates are also free as long as you use them with their services, but I don't think that applies if you have your own server. So if you want to use a certificate inside your own EC2, I haven't done that, so I'll probably still keep the service called Let's Encrypt as part of my deployment. Azure also has a service for that, so something to keep in mind there if you use Microsoft. And these services they combine with a backend encryption service. In the case of AWS, it's called KMS. So that's the service that's going to manage your key. And something cool about KMS is that if you have a rogue employee that goes in there and deletes your key trying to kill your business, they don't actually delete the encryption key. It goes into a grace period where that key is just sitting there for a while, and it will be deleted eventually. So if you detect that somebody deleted your key with the intention of perhaps putting you in a ransomware situation or destroying your business, you can always retrieve that key because it will never be deleted right away. I think the minimum is a 7-day grace period to actually execute a delete on a KMS key, right? So just something to keep in mind there, because once we encrypt data, if we lose the key, we don't have a business anymore. Everything is gone pretty much. So containers. This is what an architecture would look like if we're talking about containers. In this case, this is a Kubernetes deployment. I'm not a big fan of Kubernetes. I like to keep things simple most of the time, so I stick to the traditional AWS ECS service or Docker Swarm type of architecture. But yeah, this is the way it would look like if you are into Kubernetes, which again, it's a pretty good service. I just like to have control myself, control my own load balancers, control my own scaling. That's just me. If you don't want to deal with those architecture components, you can use something like this, like Kubernetes, which will do the load balancing for you. It will do the service discovery. It will manage the scaling of the nodes. So it's a really good tool. Nothing against it. It's absolutely great. But like I said, I like to manage my components myself most of the time. So I use just traditional cloud deployments to do just that. Now, let's take a look at some ways to keep your thing secure, your DevOps process. As we mentioned, image scanning, it's absolutely a good part of this. And also, perhaps you can start your scanning earlier by using a tool like Dependabot to check for vulnerabilities along the way while you're still in development, and everything is easier to change. What else? You have runtime security. By runtime, we just mean, something like I mentioned, Wireshark to monitor network activity, or flow logs to monitor network traffic to detect for anything unusual trying to hit your running infrastructure. Another thing to worry about is compliance. But usually, if you're using any of the cloud providers out there, they'll give you some of that taken care of. Let's say that you have sensitive medical data. There's a list of AWS services and Microsoft services out there that are already HIPAA compliant, and you can use those services. And as long as you're using those services properly, following the standard best practices, you will be fine. So you don't need to worry about whether you are inside or outside of your compliance envelope. Using a platform like Kubernetes, as I mentioned, they'll do a lot of stuff for you, so you don't have to worry too much about it. By doing so, you get a lot of performance, security, and capacity management just by using the platform itself. As I mentioned, it's my personal preference to manage all those components by myself, so I'm not a big fan of Kubernetes in this case. But know that it's out there, and you can use that as an option if you build containers. And of course, there's always cloud service monitoring, something like CloudWatch, or specialized tools like New Relic and Datadog, all those services out there that are dedicated to monitoring what's going on, right? And the important fact here is to, number one, detect anomalies, and number two, get notifications to you on your team as soon as possible. That's really the goal of number 5 here on the screen, is to be able to get those notifications out there as soon as we can, right? Because especially if something's happening, like network traffic is increasing in the middle of the night, and that's considered an anomaly, you want to know what's going on as soon as possible. Now, speaking of traffic outside of business hour, there's load balancing and firewalls. Those are components that are really critical when it comes to protecting yourself in real time, right? A load balancer, you would think of a load balancer as a way to manage traffic and spread the workload. I see it as a different thing. I see it as a way to help mitigate a DDoS attack, right? Essentially, it's basically a component that is in front of your infrastructure, and while it's there, you don't have to worry about, okay, are we being attacked? What do we do? Because usually the load balancer is managed by your cloud provider, not necessarily by you. So if you're getting attacked, you can actually open a ticket to your cloud provider and say, hey, can you help me with this thing? I'm being attacked. And they'll probably tell you, we already know. Because like I said, this component is managed. Most of the time it's managed by your cloud provider. And if that's the case, if they detect a pattern that looks like somebody is intentionally trying to crash your application, they probably know before you do, because they have 24-hour teams looking into this. And if you combine a load balancer with a firewall, things get even better, because now that you can identify a range of IPs that is attacking your infrastructure, you can just set up a firewall rule to block them out, right? And that's usually the fastest way out of the problem. This is what it would look like, especially if you have auto-scaling components, which we're going to get into in a second. People think of auto-scaling as something that you can combine with a load balancer to manage when you have a ton of customers coming in at once and then they leave, and you want to scale up and down as demand grows and then shrinks. But I see these components as a way to keep your application running when you're under attack. If you do the right combination, well, you might think something like, well, I don't want my application to scale up to 100 servers, because then I'll have to pay for those 100 servers. And I would challenge you by saying, I would say don't worry about that, because your cloud provider, if you can prove that you were under attack, that they were not actual customers using your application, they'll give you a credit. They'll erase that expense of your bill if you can show that you were under attack and you scale up to 100 servers to serve your application, but it was not legitimate traffic. So they'll give you a credit and say, hey, don't worry about it. Just as long as your application keeps running, that's what we really care for. And they'll cut you some slack there. So I also see auto scaling as a security component. So this is how it would be used on a traditional way. You have several queues sending traffic back to your EC2s, which are your producers, your applications that are actually taking in the orders or whatever it is that you're serving and processing the output that your customers want. However, like I said, this is also a way to keep your application alive when you're under a denial of service attack. And like I said, don't worry too much about it. Yes, it's kind of annoying to have 100 servers running when you only have like 3 people that are actually authentically using your application, and the rest is just somebody just trying to mess with your infrastructure. But, like I said, if you just send a message to your cloud provider and say, hey, there's all this horrible traffic just trying to crash my server, and they'll understand. They'll cut you some slack there. This is more or less what it looks like, that same thing that I just showed earlier, but this is the actual secure version. You'll have your entry point, which is your Route 53 that points to yourapplication.com or whatever it may be. And then you'll have a combination of a CDN or Cloud Distribution Network, in this case, CloudFront, since we're using AWS. And you have your Web Access Firewall. That in itself, as it is a really powerful combination because these 3 services, Route 53, Web Access Firewall, and CloudFront, they're all managed by your cloud provider, not by you, which means if something happens at this layer and it gets to your application, they're responsible for whatever expense you incur here, and they're responsible for keeping your application running just because you have all these services in front of your application. So that's something that's really good to know. That's kind of important to know when it comes to this type of situation. Now, when we hit the back end, you have your load balancer and your auto-scaling group. And like I said, some of that bad traffic will probably go through. And, you have your back-end infrastructure designed to grow and shrink to keep your application running optimally, even though some of that bad traffic may be getting through. But at that point, like I said, you can just set up a Web Access Firewall rule and block the bad traffic. So this is what you would do in a scenario where you need to protect your application in real time. Of course, this is more of the upside of DevSecOps, because at this time your application is already running and you just want to make sure that it stays running under an insecure environment, especially if you have, like I said, facing where your audience is the entire world. You need some kind of protection like this. Right? So that's what I have for you. Let's go over some key points before we move on to questions. So application security, make sure to use third-party solution for user authentication. As I mentioned earlier, do not try to do this by yourself. It's usually a bad idea and you waste a lot of time. So when you're doing an application development, just use one of the third-party solutions so that you start fresh with the user authentication and authorization mechanism already in mind. Second, keep your architecture in mind by using something like microservices or serverless technology or anything you want to do to keep your application simple, because if you do it this way, you'll be able to delegate a lot easier and just divide your application into smaller components that you can, spread across your team and develop easier and have version control to each and every one of your individual microservices. It gives you a lot easier development environment when you spread everything into smaller components. And of course, you should design for scaling. So the only way to do auto scaling is to be able to have servers go in and out without crashing your application. And the way to accomplish this is using a loosely coupled software architecture, which you can achieve by using messaging queues such as Amazon SQS or similar like that, or even something like RabbitMQ or something like that. And then you'll be able to, have your application talk to each other using messaging. Finally, specifics to DevOps, be sure to manage credentials using some sort of secret manager, as I mentioned, GitHub Secrets, HashiCorp Vault, or anything like that. And use infrastructure such as load balancers and firewalls as your first line of defense for your application. And finally, always remember to encrypt. That you can never go wrong encrypting. I understand that sometimes it will slow down your application a little bit to have to encrypt and decrypt everything all the time. That's, I guess, part of the deal. But yeah, you can never go wrong with encryption, so be sure to also do that. And with that, Gladys, if we have any questions, I'll be more than happy to answer questions from the audience.
Sure. And great presentation, Carlos. That was a lot of information for our audience to chew on and remember and, consider in the coming for their future deployment. So our first question here, on a CI/CD pipeline, what's the first step to start implementing DevSecOps?
Oh, let's see. I would say I usually start with the secrets. So in other words, if I'm building a CI/CD process, let's say to build a container based off some code that is in the repository, I start by asking myself these questions. Which passwords or other forms of sensitive data is this going to need, and where can I get it? Once I take care of that component, it gives me that peace of mind that I'm not hard-coding stuff anywhere like passwords or API keys inside my container. So I'll take that step as the first step. Great.
And then on a related question, if I don't use CI/CD, can I still do DevSecOps?
If you're not doing CI/CD, first of all, what is wrong with you? And second, let's see, how can I answer this? Well, you still need to do monitoring of your application. So I would concentrate on making sure that you have a solid and protected networking environment, and that you at least have components around your application. Like I said, it could be a legacy application, so you're not really building anything. You're just running a software that your company has run for, let's say, a decade or more, and you don't want to touch that software. So there's really nothing to build. In that particular case, what you would do is, like I said, worry about your network security, your monitoring, and collecting as many logs as possible, because logs is what enables you to create alarms and alerts when things change and get out of hand. So yeah, that's what I would recommend if I didn't have any CI/CD process, just to worry about the operational safety and security of the application.
Great. Now I'm seeing a couple of questions on DevSecOps tools, but there's a couple of them, so I kind of want to go broad, and I think this will be helpful for our audience. How would you rate the native tools that are already available for like AWS or Azure or Google Cloud? How would you assess those native tools, and how well do they work for people? And at what point should you start saying, hey, I think I need some help beyond these native tools?
That is a great question, and the way I like to answer is by measuring some kind of criteria. In this case, let's say volume. Let's say that you have, it's not the same if you're trying to monitor 20 servers versus 2,000 servers. If you get to that scale, now you're saying, okay, maybe this little open source tool or this built-in little feature is not enough anymore. Now I need something much bigger, something dedicated to monitoring and finding anomalies. As you scale, then yes, I would highly recommend going to a third party of some kind that dedicates itself to, let's say, monitoring, for example, or if you're doing CI/CD and you CI/CD to build containers or microservices, and you already have like, okay, now I went from 10 to 100 to 200 to 300. Now it's starting to get really big. Now you're no longer a 500 employee company. Now you're a 1,000+ employee company where you have tons and tons of developers producing features every single day. In that case, yes, that would be my breaking point and say, okay, no, this is no longer a feature. This is actually a business critical function. And at that point, I would say, okay, we need to find some solution that will scale with my team and provides a dedicated service to this particular task.
Great. And a related question, and actually a couple of related questions kind of going in the opposite direction. What are the parameters for when it's a good idea to only use native tools, or if it's possible to use native tools only. I think you mentioned this already, that scale is a big issue.
Yes. If I'm starting out, I usually prefer to start with the built-in stuff. So let's say that I'm just have, like I said, just one application that I'm moving to the cloud, or actually building natively in the cloud. I would stick to native features provided by the cloud provider in this case, mainly because of cost. It's right there, it's free, or I should say I'm already paying for it, and that should be pretty much it. I would stick to the basic tools because I already have them, and especially if it's a single application or two that I'm just building in a small environment. But, like going back to the CI/CD example, if you are growing or you're already a large company, I would probably recommend a dedicated tool for the task.
Perfect. Thanks so much, Carlos. It looks like that's all the time we have for questions.